We have a route salesman. In this case, it should have been a route saleswoman. But she wants to know why some of her stores sell more of her cupcakes than other stores. And she thinks that the reason is placement. So we got 3 different shelves. We got the bottom shelf, middle shelf, and top shelf. And she collected this data from 7 different stores. She wants to see if there's a significant difference between the number of cupcakes sold depending on the shelf. So the null hypothesis is there's no significant difference between the means. You can do this 2 ways. You can write H sub O, it's not sub, but the 0 means the null. So this is the null hypothesis. And it basically states that there's no significant difference between the means of anything, anywhere, ever, ever, ever. Or you could write it in English. No significant difference in the cupcake sales between the 3 shelves. The alternative hypothesis is just the opposite. There's at least one significant difference in the cupcake sales between the 3 shelves. So that's pretty basic. Remember that at all times. The null says no difference. The alternative says there is a difference. This is called proof by falsification. That's why we try to shoot down the null. If we shoot down the null, we can accept the alternative as being the correct one. The independent IV for all between group ANOVAs is always the same. It's a categorical variable. It has to be different groups. So I'm just going to name this shelf. Which shelf, right? So there's 3 levels of our IV shelf, and that's bottom, medium, and top. And the DV is the number of cupcakes, right? The number of cupcakes sold. All right, did the DV violate the assumption of normality? This is a tough one. We're going to have to do this in SPSS. Now, because our sample size is so small, there's only 7, right, per shelf, that's probably a good indication that it will violate the assumption of normality. Say that again. The smaller the sample size, the more likely you're going to violate a lot of these assumptions. But let me go ahead and put this in SPSS. There's SPSS. And I'm simply going to highlight the data. Copy. Make sure I'm in data view down here. Cell A1, paste. And then I'm going to switch to variable view. And which is which? Okay, the first one is bottom shelf. This is middle shelf. And this is top shelf. Yeah. And these are the numbers that we're going to put in there are actually scale numbers, okay? And then we're going to go to Analyze, Descriptives, Explore. Put all 3 of them in there. And we want plots. Don't use the stem and leaf anymore. Normality plots with test. That's the main one. It's going to give us the Kolmogorov-Smirnov output. And here they come. And, oh, silly me. So the bottom did not violate, right? We're looking at the sig values. The middle did not violate, and the top did not violate. So none of them violated the assumption of normality. How about that? And again, we're only looking at the histograms, and they're kind of histogrammy. All right, so no, they did not. So normality is the first assumption. You always check with t-tests and ANOVAs. Second one is you check the homogeneity variance. In other words, is the variance of the data for each group relatively the same? We're going to go ahead and put this in Excel, and we're just going to take a little shortcut. There's many ways to do this, but I'm just going to paste them here. And I'm going to check the variance of each one. Now, it should be relatively the same, but I think the limit is somewhere around 4 or 5 times the difference. So if one of the variances is like 5 times greater than the other one, then you can assume that it violated the assumption. But let's just do a little cheating. We're going to pick a cell, any cell. We're going to go to the function bar. We're going to make sure we're in statistical. And we're going to scroll down to V for variance. And we always do the s.s because that means it's a sample. So we want this, enter, and then just click and drag across. Nah, they're all relatively the same. You know, they're all within 3. So I'm assuming it did not violate the homogeneity of variance assumption. So no. So it didn't violate those 2. The third assumption is independence of observation. There's no way to check that with a t-test or the ANOVA unless you were standing there watching, making sure nobody was interfering with, group 1 was interfering with group 2 or something like that. That's independence. But let's go ahead and run our ANOVA. Let's do it first in in Excel. And let's make it pretty so you can see it. So what I'm going to do is I'm going to go to Data. I'm going to go into Data Analysis. And this is a single factor. That means one IV, one categorical IV. Input range is this whole thing. Hold on. Whole thing. And yes, I put the labels in. And where do I want the output? I want it right around here. Get in there, you. Oh, no, I'm sorry. Output range. And yeah, I want it right around there. Good. All right, let me pull this up so you can see it. There's the means, right? So bottom shelf about 15, middle shelf 16.5. Top shelf looks like it's the winner, 20. And there is a pretty big difference in there between the low and the high. It's about 6. But we're going to let our ANOVA tell us if that 6 difference is big enough to be considered significant. And there's our F ratio. It's huge, 7. And our p-value is less than 0.05. So we get to reject the null, period. So there is a significant difference. We're going to accept the alternative hypothesis, which means there's a significant difference in there somewhere. More than likely, it's between the top shelf and the bottom shelf. So the F ratio was, I had to double check. There it is right there. 7.11. Okay, 7.11. Which means that over 7 times of the variance is coming from between the groups. That's what the F ratio is. It's the explainable variance divided by the unexplainable variance. Or simply the between group variance divided by the within group variance. That's what this is, and that's a lot. So you're assuming that most of the variance is coming from the grouping, which means that the shelf you're putting them on, one of them is significantly better at selling cupcakes than the other. So what's the p-value? I believe that was 0.005. Let's look it up here in a second. 0.005. And let me do this. Let me do this. Let me do that. And let me double check. Yeah, there it is, 0.005. So p-values, we rate out to 3 place values. Any test statistic like an F or a chi-squared or a t-test, we only put out to the 2 place values. That's APA formatting. Don't ask me why. So was it a significant difference at the alpha level 0.05? Yes, there was, because 0.005 is less than 0.05. Okay. And so which one had the highest? I think we just did that. We had who had the highest? Top shelf highest, bottom shelf lowest, right? Top highest. I guess that's where all the tall people look. Come on, spell highest, high. And bottom lowest. Oh, yeah, they kind of fit. So I'm going to write this up in APA formatting. Please hold. A one-way between group ANOVA indicated that there was a significant difference in the number of cupcakes sold between the 3 shelves. F tells you that we use the ANOVA. And the parentheses. And then the first number is degrees of freedom for your between groups. So it's 2. The second number is the degrees of freedom within groups, comma 18. So 2, comma 18, close parentheses, equals, and then we do the F ratio, which we already know is 7.11, comma, the p-value, we already know that too, 0.005, done. All right, that's APA formatting. So there's number 1 for you. I'm going to show you how to do this in SPSS real quick. The problem is that the data is not formatted properly to run the ANOVA test yet in SPSS. So what we're going to do is we're going to fix it. All right, let me get rid of all that stuff and get rid of that stuff. So with SPSS, you need a categorical variable that's made up of numbers 1, 2, 3, 4, 5, etc. And each number identifies one of your levels. So I'm going to put a row in here. We're going to make the bottom shelves all ones. I'm going to cut and paste this. And those are going to be our 2s. Oops, come here, you. Because SPSS likes columns. Don't ask me why. So these are all 2s. The next ones, you guessed it, are all 3s. And it is ready to be cut and pasted into SPSS. So I'm just going to go ahead and get the numbers. Copy. Jump over here. Opens as me. Make sure I'm in data view. I'm going to right click the top open slot up there. And I got my things. I'm going to switch over to variable view. I'm going to name this one shelf. And this one, cupcakes. Yummy, yummy. And let's tell the computer what kind they are. Shelf is a categorical variable, and number of cupcakes is a scale. But since we have a categorical variable, we're going to go to values and tell the computer what the numbers mean. So number 1 was the bottom shelf. Add. Number 2 was the middle shelf. Add, and number 3 was the top shelf. And we're good to go. Okay, so let's go to Analyze, General Linear Model, Univariate, that means 1 dV. And our dV is cupcakes. And our fixed factor, so remember, factor means categorical variable. That is shelf. And we'll just go for the options. Overall, you always want your descriptives, your effect size, and your power, and your homogeneity tests. And here is the output. This is how many in each group. This is how you name your groups. There's the means. Here's the Levine's test of homogeneity variance. Did not violate, which we kind of already knew. Here is your money box. Money box. This is your between group source of variance. Let me stretch it out so you can see everything. Since we only have one IV, the corrected model row and our variable name shelf row should be identical. Get that stupid thing out of here. And we have the same thing, right? The F is 7.11. Significance is the same. But with SPSS, you get the effect size. So the effect size is about 44%, which means you can explain 44% of the variance in the sales of cupcakes based on this shelving model. Okay, you got that? But that's it. MGZ out.